On this edition of TED Talk, we will be discussing all things earthquake.
Earthquakes occur when radioactive matter heats up the inner core, which heats up the mantle. This creates convection currents that move the tectonic plates. When the tectonic plates move like this, it causes them to shift into a fault that lets out a large amount of energy that causes an earthquake to occur.
Scientists have created new technology to help stabilize buildings and bridges in the event of an earthquake. Along with technology to collect data within an earthquake, early warning systems were created that can help save many lives.
Technologies such as seismographs, which measure the size of the earthquake, can also be used as an early warning system. They are used to rate the earthquake on a scale of 1 to 10, 2 being 10 times worse than 1, and so on.
These technologies are very important to have for a number of reasons. It's good to have the technology needed in order to warn others of an upcoming earthquake, and scientists are now able to predict when, where, and how intense an earthquake will be to a certain extent. This gives people more time to evacuate an area or at least prepare. And if a family is unable to get out of their house or if an earthquake is unexpected, they have developed new ways to make buildings and bridges more stable and susceptible to earthquakes.
To test these situations, we created a model bridge, an early warning system, and a seismograph that we believed could withstand the force of an earthquake. We simulated the earthquake by shaking a board attached to a spring.
While we were testing our bridge, the bricks that it was attached to did not stay up. The bricks essentially fell on top of the bridge and bent it, ruining it. Our seismograph didn't actually collect usable data. Our warning system worked, however, the noise made from the earthquake simulator was louder than the warning itself, so it was hard to hear. It also didn't start before the earthquake started, so it wouldn't be any help in an actual earthquake.
To create a better design for our bridge, we could have made the bricks more stable for a starter. We also could have created a more stable and durable middle section for the bridge so it wouldn't cave in. A better design for our seismograph would have been putting a weight on the marker so it didn't go all over the place. Our lines would have been more accurate, and we would have been able to recognize the magnitude of the earthquake. Finally, a better design for our warning system would have been finding some way to start it before the earthquake itself began.
Although our initial experiments didn't go as planned, we now have a pretty good idea of how these technologies work. Due to our initial experiments not going as planned, we could not calculate the magnitude of our earthquakes.